Okay, good afternoon. Hope everyone's week is going well so far. Welcome to What's New with Amazon File Storage. I'm Edward Name, and I lead our file storage offerings here at AWS. And joining me today is Mark Roper, who is a principal engineer for our file storage services. And we're really excited to talk with you today about some of the innovations that we've delivered this year. We want to share some of the details about them. We want to share how customers are using some of the capabilities that we've delivered. And we also want to give you a little bit of a glimpse into how we think about where we invest and what are the types of capabilities that we are continually evolving and continually making better. And I'll start by just giving you a sense for how many things we've launched this year, how many capabilities. We've had more than 20 feature launches since this time last year at re:Invent. And this week, we're launching another 7 capabilities. So that's on average a delivery once pretty much every other week. So we're excited about the pace, and we see that pace continuing forward as well. So a lot of good, exciting things that we've been working on and we're continuing to work on. And today, this talk is not just about what we delivered over the past year. We really want to more broadly talk about several topics. The first is the evolving role of file storage in the world as data growth accelerates. The second is the challenges that are emerging with this fast pace of data growth. The third is we want to talk about the solutions that we've built and what we're investing in order to support pretty broad spectrum of cloud workloads that depend on file storage. And then finally, we want to give some details about some of the capabilities that we've delivered recently and dive into some of those details that hopefully will be pretty helpful. So let's actually start by taking a step back and sharing how we think about solving your data challenges and how that permeates what we do as we deliver new capabilities to you. And at AWS, we know that more than ever before, innovation relies on data and the ability to leverage data effectively. And that's why we commonly say that data is the basis of modern innovation. And because of data's role, organizations are reaching unprecedented levels of scale with their data sets. They're serving a really growing set of workloads in everything from analytics to high-performance computing, of course, machine learning, generative AI, and the volumes of data out there are growing at an accelerating rate. According to IDC, 101 zettabytes of data were created and replicated around the world in 2022, and that data is expected to more than double by 2026. And why is it growing so fast? Well, the growth is driven by a bunch of things, and some examples on this slide are an increasing base of video cameras and video analytics, the adoption of AI/ML, the use of simulated and virtual environments, the proliferation of IoT and other data-generating devices. So a lot of these kind of things happening in parallel, really leading to this explosion in data growth. And when we double-click to really understand what kind of data is out there, we see that the majority of that data is file data. And why is so much of it file data? Well, file data has a really rich history. It's been developed and has matured over like 50+ years. Which really means that most applications speak file, and operating systems are built around working with a file interface to data. So it's become the default and standard interface for application developers. It provides a simple, really simple shared access model for collaborating across users and applications, and there's a really wide array of file systems that are optimized for high performance, and a lot of shared file systems, for example, offer near local latencies. So these are the reasons that file really has so much of a role to play in data today. And for these reasons, it's pretty ubiquitous, and file is used across a really broad spectrum of workloads. I won't go through all of these on the slide, but you can get a feel for it's everything from enterprise IT applications to data science and analytics to web serving and content management. So really, really, really broad set of workloads depend on file at their core. And so when we talk about this growth of data, it's kind of like, well, what's the problem? Well, growth and scale are hard. They're really hard, especially at the scale that we're talking about for data volumes. And like, why is it hard? Well, it's really hard to predict future data growth. So traditional models of buying and provisioning hardware are challenging, and they really don't work anymore. It's becoming increasingly critical to optimize data storage costs as volumes grow. And then maintaining availability, resiliency, security, those things become much harder for organizations to do on their own as the volume of data grows and as the locations the data is accessed from increase and as the applications themselves grow and the number of applications proliferates. And we really look at what we offer as our file storage services as a key part of helping customers solve these challenges of growth and these challenges of scale. So like some examples of how customers leverage AWS and leverage our file storage services to address these issues. Our services provide elasticity, they provide pay-as-you-go pricing, so you don't need to provision for peak, you don't need to predict where you're gonna be 3 months from now, 6 months from now, a year from now. Our services provide real-time visibility into costs, and we do a lot of automatic cost optimization. We place data optimally in different storage classes. We do a bunch of compression and deduplication type of things. So a lot of focus on automatic cost optimization. And then in addition to providing all of AWS's security and resiliency benefits, we allow customers to manage their on-prem and their cloud environments within a single security perimeter, leveraging services like site-to-site VPN and Direct Connect. But it's not just about dealing with the scale and dealing with the growth. Businesses also want to do more with their data and with their file data. And there's this kind of really insatiable business desire to leverage data for insights and to build competitive advantage in ways that we've just never seen before. And a lot of what we see day to day, a lot of the discussions that I have with customers are about organizations figuring out how to use all their data with innovative AWS services that let them do more with the data, get rich insights from the data. And so a big part of our focus as well within the file storage space is making sure that a lot of AWS's services work natively and seamlessly with your file data so that you can really get more from the data. And so we talked like a few minutes ago about the use cases and that really broad set of use cases. And so how do we think about serving such a broad set of use cases since a lot of them have very different needs? Well, really what it comes down to is we focus on serving 2 different types of individuals. The first are enterprise storage and application administrators. And these are folks that have traditionally deployed file storage on premises. So they've typically spent years developing administrative processes and developing workflows that rely on the APIs and the capabilities of particular storage solutions from vendors like NetApp. They tend to be experts in storage, and they want really granular control over their file storage. They want to really have the last level of control over how they manage it. And when moving to the cloud, what they commonly want is they want all of the benefits of the cloud, so the agility and the scalability and the economics and the ability to do more with their data, but they also don't want to give up the capabilities that they've become used to on premises for managing their data. And they want to be able to have access to the same APIs and the same management features and functions so that they don't have to change all of their management processes. So that's one group that we spend a lot of time focusing on. And then the other is builders and data scientists. And that's kind of the other end of the spectrum. These are cloud-native application builders, cloud-native data scientists, and they're not migrating data from on-prem NAS. They're developing and deploying new apps and new workloads in the cloud. And so what are they looking to do? Well, they need to, at its most basic form, share storage across multiple compute resources. But they don't rely on specific NAS capabilities, specific performance profiles, specific APIs. They really don't have any of that need. They really just want really simple shared storage. And they don't have a storage background. And what they ideally want is they want to create an endpoint for their data, mount that endpoint from any type of instance, any container or serverless function, and just go. And the types of applications that we're talking about are SaaS applications, maybe user shares for data scientists, DevOps tool type of workflows. So those are kind of the two different sets of folks that we spend a lot of time obsessing about. And although it is a pretty broad set of workloads that we really try to serve with file storage, we do see them all fitting into kind of three categories of use cases. And we spend a lot of time thinking about how do we really enable those use cases. So what are those? Well, the first is user shares and enterprise apps. And so think of that as kind of traditional NAS, shared storage that almost all medium and large enterprises have, commonly exposed over NFS or SMB, often integrated with enterprise identity systems like AD or Kerberos. And it's things like file shares, enterprise applications, ERP, HR apps, analytics tools that have been developed over decades. The second is what we call compute-intensive workloads. Those are applications that rely on really high-performance shared storage to support really demanding data processing. So think of like clusters of dozens or up to thousands of CPU or GPU instances. And the name of the game there is you don't want your storage to bottleneck your expensive GPU. Like the last thing you want is for your GPU or your CPU to be waiting for your storage. So you really want your storage I/O to keep up. And so it's things like genomics analysis and semiconductor chip design, high-performance computing, a lot of machine learning and AI type of applications. So those are the compute-intensive workloads. And then the third category is what we call cloud-native applications. And that's really more of kind of the builder persona that I was talking about, where you have applications that are built for the cloud. They just need shared storage. They don't need NAS like a broad set of NAS capabilities. They just want full elasticity, simplicity, and think of things like SaaS applications, DevOps platform development, data science use cases. So those are the three areas that we really think about as we think about building capabilities. And how do we serve those? Well, we have the Amazon FSX family, which is really focused on user shares and enterprise apps and compute-intensive workloads. And we have Amazon EFS, which is really focused on cloud-native applications and builders. And so let's just talk about each of those quickly. For FSX, think of it as the file storage analog of RDS. It provides the most popular file systems. We have Windows, NetApp Ontap, OpenZFS, Lustre, and provides them as fully managed single-tenant deployments. And it's really our default recommendation, our default solution for storage and IT admins that are bringing NAS to AWS, because it really has those kind of like-for-like features that those file systems have that folks are running on-prem. We provide it in the cloud, but fully managed and kind of with all the benefits of the cloud. And then with its high-performance file systems, so OpenZFS and Lustre, FSX is also our default solution for the compute-heavy ML, AI, HPC, compute-intensive workloads. And then we have EFS. EFS is a serverless file system, delivers an elastic, really simple experience for sharing data across compute instances, and it's our default solution for those builders I was talking about that are looking for simple, shareable data in the cloud. We've designed that experience to align with what builders want, so a serverless solution and the full elasticity. And as we think about the areas that we invest in, we typically gravitate around these three areas that are on the slide here. So the first is performance. Second is data management and resilience capabilities. And the third is cost optimization. And so let's jump in and talk about, across these areas, how we've invested in those themes over the past year. And if we start with user shares and enterprise apps, and we're going to start with performance. Performance matters, and we're never done, frankly, with raising our performance bar. So ARM is a name that I'm sure a lot of you are familiar with. They're a technology provider, a leading technology provider of semiconductor IP. Their IP powers billions of devices out there. And one of the things that we've heard from customers like ARM, and they're an FSX for NetApp Ontap customer, is they love Ontap's capabilities. They love FSX's capabilities. And they're using FSX and FSX Ontap for a pretty wide set of chip design workloads. But until this past week, some of their most performance-intensive Ontap workloads required much higher levels of performance than they could get from a single Ontap file system. So in some cases, that meant that customers couldn't use FSX for Ontap. In other cases, folks like ARM would actually use multiple Ontap file systems and essentially try to shard data across them and have compute instances mounting multiple file systems and just a bunch of management and complexity overhead that's just not something that customers want to do. And so we were really excited this week to announce that we're launching Ontap file systems, FSX Ontap file systems, with much higher performance limits. And we call these file systems scale-out file systems. And so with these file systems, you get a 9x increase in read throughput. So before you could get 4 gigabytes a second of throughput, now you can get 36 gigabytes a second. It's 6x increase in write throughput. So we went from 1 to 6 gigabytes a second. And then a 7x increase in IOPS. So from 160,000 IOPS to 1.2 million IOPS. And this is all within a single file system. And let me talk a little bit about how it works. Essentially, it works by scaling out the file system cluster. And so on today's Ontap file system, or I should say before this week, there really, you could think of each file system as having 2 servers that make up the file system. One is an active node and one's a passive node. And data is replicated between those nodes for resiliency. And then when the primary node fails, file system traffic automatically fails over to the secondary node. And so essentially what that means is it's highly available. So if a node goes away, data is still being served. But that was what we offered until this week, which was a single high availability pair of file servers. And you could probably imagine that the constraint there is that it's 2 servers, and really it's 1 server at a given time delivering traffic, so there's a limit to how much a single server can serve. And with scale-out file systems, you actually launch these scale-out deployments that have multiple HA pairs. And so you have multiple pairs of servers that are serving traffic to your clients. From the client's perspective, it all kind of works magically, and they're not really aware that there's these multiple servers, but what's happening behind the scenes is you are scaling out your cluster of servers. And with what we announced this week, we can scale to 6 HA pairs, and that's how you get to the performance numbers that we talked about earlier. And then earlier this year, we also meaningfully increased performance on FSX for Windows. And we didn't do that by launching scale out, but we actually are leveraging the most up-to-date AWS infrastructure under the hood to get significant performance benefits. And so for Windows File Server, we have a 6x increase in throughput. We have a 5x increase in SSD IOPS and a 10x increase in the number of IOPS that you can provision per gigabyte of data. So pretty meaningful performance increases for Windows applications. And then a big part of what enables FSX to serve such a broad spectrum of file workloads is the really rich set of data capabilities that it provides. So for example, NetApp has invested decades in building a really rich set of data management, data access, and data protection capabilities into its ONTAP file systems. And along with a wide variety of storage efficiencies and support for hybrid architectures. And FSX for ONTAP is the only complete ONTAP in the cloud, running in the cloud as a fully managed service. So it means that you get all of these capabilities. And this is a big part of what draws people to FSX. And to give you a sense of how much these data capabilities matter, eHealth NSW was looking to migrate. They had an enterprise image repository, and they wanted to move it to the cloud and move it to the cloud really quickly. And their workloads and that particular application relied pretty heavily on on-premises ONTAP storage. And ONTAP, because it provided a full set of NetApp's data management capabilities and data movement capabilities, including snapshots and SnapMirror, it allowed them to very quickly and easily move their data to the cloud and also use the same kind of management processes and and storage optimizations that they're used to on premises. And the results have been pretty great for them. They've seen a 10-fold improvement in performance, 70% reduction in critical incidents. They said what they didn't really expect, or they didn't think it through necessarily at the start, was they can actually implement enhancements to applications up to 50% faster than they could, because they can now launch environments in under 4 hours to conduct testing. In the past, that would have taken like 6 to 8 weeks. And they've already recognized $16 million worth of benefits due to avoided costs. And so for these reasons, we really do continue to focus a lot on how do we expose even more data management capabilities to our FSX offerings. And a big part of our focus this year was on that with FSX for Ontap. And in July, we introduced SnapLock on FSX for Ontap. And SnapLock is the first and only fully managed cloud file service with write once, read many data protection capabilities. And it means that SnapLock with your data is immutable and indelible, so it's protected against modification or deletion of files. And really, it acts as a line of defense against ransomware. It also allows companies to meet compliance requirements. And there's 2 different modes to SnapLock. The first is what's called SnapLock Enterprise, and that protects files against modification and deletion, but it allows authorized users to delete files if necessary. And then there's SnapLock Compliance, which is like a more lockdown form of SnapLock, where data cannot be modified or deleted by any user until its retention period expires. And that helps to address a variety of government and industry-specific mandates. And then let me touch on 2 of the ONTAP data management capabilities that we announced this week. The first is for shared VPCs. You can now create multi-AZ file systems in shared VPCs. Before you could create single AZ ones, and now you can do multi-AZ ones. So it's pretty important for a variety of larger enterprises that have multiple VPCs, and sharing across VPCs is a big part of how they operate. And then we also launched the ability to manage flex groups from within the AWS console and CLI and SDK, and also to take backups of your flex groups. So for those who aren't familiar with flex groups, there's actually 2 different types of volumes that ONTAP provides. So flex vols are kind of the standard ONTAP volume, and they're for general purpose workloads. And then flex groups are purpose-built for higher performance and storage scalability. And they essentially work by storing data across multiple ONTAP collections of disks. And so the ability you could create flex vols before, but you had to use the NetApp CLI, and now this is all exposed through the AWS CLI. And I'm going to actually turn it over to Mark.
Thanks, Ed. Hey, everyone. I'm Mark Roper. I'm an engineer on AWS File Services, and I'm going to talk about compute-intensive workloads. So to serve our most demanding file storage workloads on AWS, we offer 2 fully managed open-source file systems, and that's FSX for Lustre and FSX for OpenZFS. And so Lustre, if you're not familiar, is the world's most popular parallel file system. It's open source, and it's really used in supercomputers in universities and national laboratories, where it was originally developed, for all sorts of compute-intensive workloads. FSX for Lustre supports up to a terabyte per second of throughput in a single file system. OpenZFS offers the lowest latencies of any of our file storage solutions on AWS, as low as a few hundred milliseconds per operation. And it also offers a broad range of data management capabilities that are in the ZFS file system and built upon by FSX. So we launched data management capabilities and cost optimization features in both of these file systems this year that I'd love to share with you today. First, when we launched FSX for Lustre in 2018, we saw adoption across a broad range of the HPC workloads where the file system was originally developed, to serve on-prem going back years. And that wasn't a surprise to us. That's why we built it. These are workloads that are oil and gas, seismic workloads, physics simulation, video and image processing, financial services, healthcare and life sciences, genomics, analytics, a whole long list of of things that Lustre serves really well. We were pleasantly surprised in the era of GenAI that we're all living in now, how much adoption there has been for FSX for Lustre by AWS customers working on GenAI. It's not a surprise when we think about it because it's all really about performance. GenAI research and training workloads are a lot like traditional HPC workloads. They are compute intensive, typically using hundreds or thousands of CPU or GPU instances. They tend to read training data from shared storage, and then they often write checkpointing data back to shared storage while workloads are ongoing. And so the performance requirements of these workloads are quite high. Compute clusters, as Ed mentioned earlier, on these really performance-intensive workloads are very expensive, and so it's critical that you have storage that can serve the needs of those large clusters. And Lustre's consistent low latencies and very high aggregate throughput are a really great match for GenAI customers for this reason. Okay, so on AWS for GenAI workloads, we have Amazon EC2 Ultra clusters, which provide access to supercomputing class performance for everyday ML and HPC developers with an easy pay-as-you-go model. So EC2 Ultra clusters deliver up to 30,000 Trainium GPU instances or up to 20,000 of the latest NVIDIA H100-based instances in your Ultra cluster. And Amazon FSX for Lustre is really the storage infrastructure for these Ultra clusters, delivering the hundreds of gigabytes a second or up to a terabyte per second of aggregate throughput and millions of IOPS to these Ultra clusters. So Ultra clusters give customers on-demand access basically to a supercomputer along with FSX for Lustre for storage to cut their model training times, from weeks to days and hours in some cases. To train ML models with file-based workloads, if you have your data on S3 in an S3 data lake, we also integrate FSX for Lustre with S3, so you can link your FSX for Lustre file system to your S3 data lake. And then data stored in S3 is automatically loaded into Lustre when your workload starts accessing that data, where it's processed. And you can optionally configure your FSX for Lustre file system to push data back to S3 when your workloads are complete, which minimizes manual data management and copying and gives you the high-performance file interface that your workload may require. So using FSX for Lustre with S3 this year, LG AI Research developed EXO-1, which is a 300 billion parameter multimodal foundation model composed of images and text. And LG, when they talk about the benefits of coming to the cloud and AWS file storage, talk about not needing to manage their own hardware, their own infrastructure, not needing to provision that. They pay for what they use. When they're done, they stop. And they were able to reduce the costs of training EXO-1, estimated against their previous methods by 35%. And that was with S3 as a data lake, FSX for Lustre acting as a high-performance file cache in front of that data lake, and using Amazon SageMaker. So when performance and scale are massive, the importance of managing cost is also really important. Something that customers with S3-linked file systems of FSX for Lustre have been asking us for is the ability to have more control over how they clear data out of their S3-connected file system when their workload is complete. This way, they can make space on the file system for more data and to run subsequent workloads that may be linked to different buckets or different prefixes in their bucket without having to expand the size of their file system or manage what's on the file system directly. So that was in August. In August of this year, we launched a capability to give customers the ability to call an API and clear data that's no longer needed from their FSX for Lustre file system, freeing up the storage capacity for subsequent workloads. When we do this, the metadata about the structure of your bucket remains in the file system. So if your workload does need to go back and re-access data that was previously loaded, all of that is transparently reloaded back into your FSX for Lustre file system. And so this new capability gives you direct control over the size and cost of your file system and helps you make sure you'll never run out of space. Really what it does is it lets you keep an FSX for Lustre file system acting as a cache in front of your bucket in a long-term way without needing to spin them up and tear them down. Also on the theme of managing cost and performance at reInvent this year, we're announcing FSX for Lustre on-demand throughput scaling. And so with on-demand throughput scaling, you can, with a click of a button in the console or by using the AWS CLI or SDK, you can make a call to increase or decrease the throughput capacity of an existing FSX for Lustre file system. And so until today, customers who wanted to reuse the same file system for multiple workloads would really need to provision the throughput capacity of that file system for their peak workload. And then if they're, some of the time running workloads that are not as intensive and don't need the throughput, they're stuck having to pay for that capacity or sort of tear the whole thing down and create new infrastructure later. And so with today's launch, you can use long-lived file systems and you can optimize your cost by reducing throughput capacity when you don't need the throughput, and alternatively to burst capacity by increasing the performance of your file system when you're running a particularly compute-intensive workload. And so you can use this capability today on your FSX for Lustre file systems that are S3 linked, new and existing ones. And it's an exciting new way for you to run your workloads, your high-performance workloads, without trading off that performance and the cost. Do it all at a lower cost. Okay, so that's FSX for Lustre, our file system storage optimized for the highest scale. But there are many compute-intensive workloads that run on AWS that are latency sensitive, or they have lots of operations on tiny files. And for these workloads, they don't necessarily need the scale-out performance of a parallel file system. What they really want is the lowest possible latencies that you can achieve by having a single active file server node. And that's really why we launched FSX for OpenZFS, to support these latency and IOPS-intensive workloads on AWS. So let me talk a little bit about what we've launched recently on FSX for OpenZFS. So in August, we launched a new feature that enables you to create OpenZFS file systems deployed with two nodes, an active node in a single availability zone and a standby passive node in another AWS availability zone. And by deploying your OpenZFS file system this way, you're able to achieve much higher resilience. So you can run applications like critical database applications, line of business applications, web server applications, where you require really high, basically continuous availability of the file storage. So FSX for OpenZFS multi-AZ file systems support 4 nines of availability, so 99.99% of the time the file system will be available on the data path, and enhanced durability as well. And so you can launch multi-AZ FSX for OpenZFS file systems today in the console or the AWS CLI. So companies like Hatch are using OpenZFS because they love the performance. Hatch is a cloud-native gaming company, and they're using OpenZFS as part of their global hosting platform as a repository for the data that they're hosting there. They love the performance of ZFS, but they do have one challenge. So Hatch's use case requires it to replicate data across multiple file systems that may be in different regions or different availability zones. And they do that today by using open source copy tools, but it's a challenge because they need to manage their own infrastructure to do this. And it's something they're not interested in doing. It's not core to their business, but it's something that they need to do for this application. So for use cases like Hatch, where data needs to be repeatedly replicated, today, or this week at reInvent, we're really excited to announce that we're supporting on-demand data replication for OpenZFS. And so on-demand data replication enables you to easily and efficiently transfer incremental point-in-time snapshots from volumes on one file system to volumes on another file system. With on-demand data replication, you can leverage the speed and the efficiency of ZFS send and receive technology. And with just a few clicks, you can easily create this resilient copy of your data across multiple file systems. This is really used for like read replica workloads. It's used to create custom data replication workflows where you want to run active workloads in multiple localities and to act on the same shared data and keep them updated over time. It's also a great way to do disaster recovery. So on-demand data replication is also faster and more efficient than using copy tools because it's able to use incremental snapshots and only replicate the data that has changed between multiple replications. It also does this with compression. So we have customers in financial services and in media and entertainment that use ZFS send and receive replication technology on-prem, and they're now able to do those workloads here on AWS using FSX for OpenZFS. Okay. So how does it work? FSX for OpenZFS on-demand replication uses ZFS snapshots. So you take a ZFS snapshot of your data set, and then FSX manages securely sending that snapshot over the network from one file system to another, automatically retrying if there are any interruptions, and making sure that that transfer is done in a secure way. And then snapshots are received on the receiving end and then applied to the destination. And it's this incrementality over time that's really where the value comes. You can end up with very large data sets that are being incrementally replicated over time, and you're only replicating basically the churn that's occurred on the source to the destination over a period of time. Okay. So that was compute-intensive workloads. In cloud-native applications, as Ed mentioned at the start, we serve cloud-native applications with Amazon Elastic File System, or EFS, and this was launched in 2015. And EFS is the default choice for application builders who need shared file storage that's really simple, where they don't need to manage the storage themselves. They don't want or need the hands-on capabilities of a storage administrator. What they really want is to never run out of space and always have the performance that they need when their application desires it. So first, on EFS, we've been continuously investing in improving the performance of EFS over time. And so just to give you a sense of the timeline here, at reInvent 2022, we reduced file operation latencies by 2x. And so customers running latency-sensitive or serial workloads just started running faster. In April of this year, we increased single file system throughput 3x to 10 gigabytes a second of read and 3 gigabytes a second of write throughput on a single file system, enabling a whole new set of streaming workloads that otherwise weren't able to use EFS. At Storage Day this August, we announced a more than 3x increase in single file system IOPS. And then for reInvent, this week, we're announcing more performance improvements. So starting this week, Amazon EFS delivers up to 250,000 read IOPS for frequently accessed data, and that's a more than 4x increase to the prior limit. With these enhancements, you can continue to benefit from simplicity and the elasticity of EFS that Ed had mentioned, while running even more IOPS-demanding workloads on Amazon EFS. And this includes workloads like Kubeflow, big data processing workloads with Apache, Spark, or Hadoop. And these new limits are available today on every EFS file system. Okay. Along with the investments in improving performance, we're also making investments in how you manage your costs on EFS. So when you use EFS today, you're basically getting 3 benefits. First, you're reducing your operational costs relative to being on-prem. As Ed had mentioned at the beginning, if you're trying to figure out what your workloads are going to need for the next year or 3 years as you provision hardware, it's a challenge. You have to make sure you get enough. If you're wrong, it's costly to pivot, and you need to provision more hardware, potentially find new space. So none of that applies with EFS, right? You're just mounting a file system and putting as much data into it as you'd like. You're paying for what you use, and you're never running out of space. Second, EFS's bottomless storage and elastic throughput mean that you don't worry about over-provisioning. There's never a problem of paying for more than you're using. You're only paying for what you use. And last, maybe most interestingly, EFS is automatically moving your colder data to lower-cost storage for you. And I wanted to talk a little bit more about that. So EFS today has 2 storage classes. It has a high-performance SSD standard storage class and a lower-cost, infrequently accessed storage class, or IA storage class, for cold data. EFS also has lifecycle management, which is an existing capability that supports moving any files that are not accessed for a configurable amount of time from the standard storage class to the IA storage class. So data remains in the file system, the EFS file system, when it's moved between storage classes. And if a workload accesses cold data, that data is still available to the application, and it can be moved back to the standard storage class automatically. So by having both of these capabilities, the IA storage class along with standard and lifecycle management, EFS eliminates the need for you to kind of manually manage where your data is stored in order to optimize your costs. So just to give you a sense of the value of this, so for SAP, they use EFS to provide shared storage between nodes for their SAP RISE deployments, which they manage on behalf of their customers. And in 2023, they were really looking to do cost optimization in a serious way. By taking advantage of the cost optimization features of lifecycle management and infrequently accessed storage tier on EFS, they were able to reduce their overall bill by 40+%, while maintaining the same performance for their workloads, and not making any changes on the application side at all. So they use lifecycle management to tier their data into the IA tier. They also made a change to use EFS elastic throughput, which is an existing capability. Rather than provisioning throughput to elastic throughput lets you just use the throughput that you need and pay only for the throughput that you use. They were able to reduce their bill by 45% in that component of the bill as well. Okay, so EFS is getting even more affordable this year for reInvent. We're announcing a new storage class for Amazon EFS called Amazon EFS Archive. And it's a storage class that's cost optimized for your coldest data, and this is data that you're really going to access a few times a year or less. This is really a great feature for customers that want to retain data that's quite cold, maybe for future use, for AI or ML, who knows, or for retention requirements, where you're simply required to retain data for a certain number of years, and you need to do so in an affordable way. So EFS archive storage costs less than 1 cent per gigabyte per month, so an incredible price. And it supports the same lifecycle management experience that I explained previously. So you can configure, how many days your cold data needs to quiesce in your IA tier before it's automatically moved by the system down to Amazon EFS archive. And again, same point is for IA and standard. Your applications that are mounting your EFS file system, they don't know about any of this. All of the data is available to the application, and should the data be needed and used by an application, it's accessible in real time. Yeah, so to reiterate, with the EFS archive storage class, you can save up to 50% on your bill for your coldest data while preserving that valuable data for future use and to comply with retention requirements in a cost-effective way. So those are the new announcements we have for EFS this year. With that, I will hand it back over to Ed.
Okay. Thanks, Mark. Gone? There we go. So just in closing, we've talked about a few of the capabilities we launched this year. We talked about how we think about where we invest and thematically how we invest. And what I want to close on is my favorite slide, which really is kind of a thank you. It's an honor to serve so many customers. Our investments really do come from what we hear from you. We show a few examples of some of the companies who are using our file services to do pretty innovative, pretty amazing things. And this is really, truly what motivates our engineering teams and our product teams. And so I just wanted to close on that note with a thanks. Okay, well, thanks, everyone.
Yeah, thanks, everyone.
Take care.